Okay, so I can start, yeah?
Yes, just let's wait for a second. There's a small delay.
So give me a sign.
Okay. All right. Hello and welcome to the YR 2020 session. And our today's theme is Shiny and Viz. My name is Krzysztof and I'm your host. With me, there are 6 wonderful guests ready to share our knowledge with all of us. And please ask questions inside the YouTube chat and follow-up questions on our Slack channel so we could go back to them after the session. Our first guest is Grzegorz Stolecki, and the title is Using R in Power BI. Grzegorz, the floor is yours.
Okay, thanks, Krzysztof. Hello, everyone. I'm Grzegorz Stolecki. I'm from Tychy, Silesia, Poland, and I would like you to show you how R language can be used in Microsoft Power BI. Power BI is a well-known tool for analytics and business intelligence, and you can use R in this tool, the data source, data transformation, and I think the most important and most effective way as a source of visuals. First, I will show you how to configure this tool. By the way, this tool is completely free. It is available as a desktop application and also as a web service from Microsoft. Okay, so first thing, you must have R distributions installed on your computer. You can have more than one. And first you must go to the settings of this tool and set distribution you want to use. As you can see, there is a section R scripting. It is very interesting. It is also Python scripting. So if will be a conference, maybe I will show the integration for Python. Here you select distribution of R. As you can see, I have only one. And also you can select your preferred tool for editing code. For me, it is R Studio. And that's all. Then you can use R as a data source, as a data transformation, and as a visualization. First, I will show you how to take a data from R. We have a get data option, and I select R script as a source. Okay, as you can see, there is a lot of them. I see R script. And the communication is via data frames. Here you can enter any R script you want. You can read the data from internet, from text files, from a standard data set in R. So I will use the third way. So I can take well-known iris data set. For communication with Power BI, a data frame is required. So I must place my data frame in an object, for example, my data. And that's all. I can press OK. And now the data will be loaded. First, I can select a data set because your script can return more than one data frame. It is very usable, for example, for constructing relationships inside the Power BI data model. So if I select my data, as you can see, well-known columns with data. If you want to transform data inside Power BI, you can do this. I will show you. It is Power Query Editor. Power Query, it is a language and visual tool for making any transformation of your data. And I will show you the query, which is executed. As you can see, R is used by a special function, R execute, and the only parameter of this function is a R script. As you can see, there is a code snippet I entered in the previous dialog window. Okay, now I can do with this data anything I want and load into Power BI. Close and apply, and the data will be loaded into data model in Power BI. Now having a data, I can use all the tools I have in Power BI. Simply, you can check a simple scatter plot. I select variables, OK, and make a plot. I think you know this plot very well. But I used a Power BI visual to have a chart drawn for me. But also I can use R language as a chart maker. How to do it? I will show you a very small example, and then I will show you more complicated things. In Power BI, there is a special visual called R script visual. I will place it on my report. And I have script editor to enter my data. If I want to plot a data from Power BI, I must select what data I want to have in a data set which will be transferred to R language. As you can see, the preamble of your script is visible here. So as you can see, the data frame will be constructed. And sometimes this step is some kind of issue. Unique values you will have. Any duplicated values will be removed from a data set. And then I can use this data set with our language. For example, I can issue again a very simple script. How the visual is transferred. Everything which will be drawn on a standard R graphics device is transferred to Power BI as an image. As you can see, I have a chart on the screen. The R script was executed. Now, and it is a very comfortable thing, I can connect the chart drawn by R language with anything created by Power BI. For example, I want to filter out this chart by the species. Okay, so I drag species to a report field. And now I can select one of them, and the R script is executed again, and the chart is refreshed. So I can observe my data with changing filter criteria, which is also transferred to a data set. So simply, the data set from Power BI is filtered out by filter, and filter data set is transferred to R. What the communication is done behind the scenes, of course, everything is first written to a simple flat file, to a text file. Then R is called as an application from Power BI. So there are some limitations in data, a number of rows which are transferred between R and Visual, and R and Power BI. Okay, so how can it be used? One more thing, when your code in R Visual is more complicated, you can run the RStudio as selected in settings, and you can change and test your code. As you can see, there is a thing which is copying a data. First, Power BI writes a data into a temporary folder with temporary name, and then a dataset object is created with read CSV function. So in the next line, you have a standard data frame, and you can do anything you want with this code. So you can test your code in RStudio. There is only one-way communication. So if you change a code here in RStudio, you must simply copy this code via clipboard again to Power BI editor. So it is a little drawback of this thing. How it can be used, I will show you some samples. For example, clustering. And if you select visual, you can, of course, see all the script which is done. Some parts of our visuals are created as common controls, common visuals by Microsoft. For example, well-known correlation plot from Core Plot library. There is no R code in this visual. There is no R editor, as you can see, because it is a standard Power BI visual. It is written with R integrated with TypeScript, because every visual in Power BI is written finally in TypeScript. So if you want to select such visuals, you can simply connect to App Source from Microsoft, and you can find, for example, visual you are interested. Okay, and there's no correlation plot. And some of these visuals are using R, for example, this. And the source code is available on Microsoft GitHub, so you can check how it is done, how R is integrated inside Power BI component, which can be used without any R code in the tool. If the visual requires some libraries, they can be automatically installed by Power BI, or you must install them manually, for example, via RStudio. I will show you some other examples of visuals. As you can see, there are standard ggplot charts used by these reports. As you can see, it is a standard R code. So we can simply, for example, copy R code from, for example, rgraph library or from ggplot manuals, tutorials, and you can use it as your chart. It is very important for me for two reasons. The first reason, no one can say that Power BI can't draw any visual. For example, if you want to use a diagram, of course, there is no such visual in Power BI out of the box, but I can use R code to simply display everything. I practically use this, and I will show you the last sample, because who am I? I am a database administrator. I work with reports, and very often I have a problem with performance of some reports. Databases I administer have a lot of reports, thousands of them. So for me, it's very important to select a report which is a problematic one. And I can use, for example, a clustering method. This is a live tool I use at my customers' sites and customers' servers. And those data there are from one of my customers. Of course, they are anonymized. And as you can see, I have a lot of reports. And using a principal component analysis, I take a lot of parameters from execution log of the reports, and the tool automatically select for me outliers. So if you see, I must check report 1116 or 203 because they are different from others in some way. If I don't know what the way is, I can check, for example, with more visual. For example, I can check what execution count, how execution count is changing during a time. As you can see, for example, for report 113, there is some kind of seasonality. So I must take into account that there are days in the month, it is a start of the month when this report is executed more and more. And also I can quickly, by time series decomposition, spot accidentally higher number of execution. So I can quickly select the reports I must consider into further analysis of the performance. And also I can very quickly, if I want, explore the data visually. So this is the more important benefit of this integration. You can use very effective R visuals with easy exploring data in the Power BI. And this is a clue of the integration. Okay, that's all. If you want to ask me questions, I will be available on a YouTube stream and on a Slack channel. So please don't hesitate to ask any question. And I hope you will try this tool in your data analysis. Thank you very much.
Thank you very much. That was awesome. I believe there's a question inside our YouTube chat. So if you could please take a look at it, and we'll start with another guest, okay?
Hi, hello everyone. give me a moment to share my screen.
Yes, I'll just say that our next guest is Jakub Stępniak, and the topic is deployment strategies for Shiny apps.
Okay, thank you. Yes, as you said, Krzysztof, I'm Jakub Stępniak. I work for Analytics. Maybe you know this company. As our Shiny developer, and I would like to tell you a little bit more about deployment strategies for Shiny apps. You can see some resources over internet about this topic. However, I would like to show you a little bit opinionated version of it, what works and what doesn't work for me. So let's start with simple app, Shiny app. I've got one. And we've got some data loading inside of it. One thing is loading data shared between users and between different sessions. And it's going to take us 5 seconds to load this data. And also we load some user-specific data like username, and it's a little bit shorter. Later, we've got also some calculations triggered by pushing the button inside the app. So this kind of the app is going to show different places where we've got some delays in the app. Okay, let's start it. As you can see, we don't see UI yet because we are waiting for this command between all sessions loading of data. And with that URL, we've got this application. As you can see, it's quite easy and simple. We've got this hello Elliot, and then we've got calculate button. If we are going to visit this URL, you can see that we are waiting still for the user-specific data every time we run some session inside the Shiny app. And with calculate button, we've got this 10 seconds to calculate something. And as you can see, we cannot start new session. We cannot do any calculation inside of app until we have this calculation done. So again, I push calculate and I have to wait until this calculation is done to visit the website. So this app is quite good for one user, I would say, but not really for multiple users that are going to use this app at the same time. Okay, so we've got this simple approach with some public IP address. We can share the URL with our users, but it's not the best approach. So what specifically can we fix, or what is the problem with this app? So Shiny app is executed in one R process that has no support for parallel tasks. We want to load a huge amount of data, or at least make some calculations or preparing the data for the users. So it takes some time and we have to deal with it. And also, if we will try to throw hardware at the problem, it will be expensive and still we'll see some delays inside the app. Okay, so we can deal with this problem in two ways. One way is software development approach. We will try to optimize this app to remove some issues inside of it. So what we can do, we can define very well this split between global part of data loading, of preparation of the application, and the user-specific session part. And this global code is executed only once when the app is run for the first time inside this run. So if we try to redeploy or restart the application inside our studio, we'll have to wait again for the data loading. About this data loading, we can still do some things. One thing is lazy loading. We can wait until data will be needed by the user. So until it will be required by some action of the user, we don't have to load it. We can load it later. This is one way. We can also pre-calculate this data set a little bit. For example, do some predictions and load them to the Shiny app inside the dataset. We don't have to make them on the fly inside the app. Also, to avoid this blocking of user interface, we can use some plot caching and use some pre-calculated data sets. There is one way to use more than one R process. We can use futures and promises. However, it's harder to debug. It's harder to understand. We can have some issues with race condition. For example, something will be displayed before something else. So if you have some specific parts of the app that you can optimize in this way, do it, but really you cannot use it for everything. Okay, so there is also the second part, this DevOps part, I would say. And we can deploy this app in many different ways that will deal with these limitations of this simple example. So the first option is Shiny Server. I think it's the oldest one from the list. You've got two versions, open source and pro version. It's quite pricey, and I think it's not, I can be wrong, but I think it's not not in the active development, not so active as in the past. I think the emphasis is put on some other solutions from our studio. Another option is Shiny Proxy, which is all open source. You have to Dockerize your application, put it into containers, but I think it's valuable still for all, I think, bigger Shiny apps to have them in containers. So it's worth it. We've got RStudio Connect, which is quite pricey. We've got Shiny Apps IO, which is subscription-based, but still there is a part that you pay as you go. If you compare prices with, for example, AWS Fargate, I think they are fine, maybe double the price, but still you've received a lot of things, for example, for management, maintenance of the apps, so it's worth it, in my opinion. There's, of course, RStudio Cloud, which is not really for Shiny apps. You can do it, you can have public IP with some port, but you don't get all this reliability that you will have with Shiny Server or Shiny apps. So for example, if there will be some exception inside your app, it will not be automatically rerun. And the last option, I hope I will have enough time to say a little bit more about it, is custom-made deployment. You can use, for example, Azure or AWS services from public cloud. Still, it's a good idea to Dockerize your application, but with that in mind, it's limitless, I would say. Some, of course, scripting will be needed to achieve this. And the last option, which is not really about deployment, is to share your app packed. So there will be no multiple users. Users will run the app inside their RStudio locally. Some training is required for your users, but I think if you have no secret API keys or you don't have database connections, things like that, and also, of course, you are able to share your source code, I think it's quite a nice option. Okay, so let's review some cheap or free options from the list and how we can use them to avoid the limitations of R and also of open source versions. So probably authentication will be useful for us, and also removing this limitation of single R instance. One thing you can do with Shiny Server open source is for sure having multiple copies of one app, because you still have this limitation of single thread per app, but you can have multiple apps and one per user or one per session. In the past, for example, I had a bunch of apps for different markets, and it was simply one instance for every market. And they will have some different URLs. So what you can do about it, you can put reverse proxy in front of it, for example, Nginx, with some basic authentication, for example, or just custom-made web app with iframes. I'd like to put emphasis on one thing. So if you have apps in iframes or with some redirection, ensure that this app cannot be run without the proxy or without this manager of the apps. So for example, you can use tokens, secret keys that are put into URL and are checked on the app side for validity. You can even go further and have some one-time tokens or tokens with limited validity. And one issue is that the first user of the app will have to do this global data loading. And you can avoid it by running this app earlier on your own. Still, you have some limitations by timeouts that will kill the app if it will not be used, and also by simple scheduler, which limits the number of sessions that can run at the same time. Okay, so second option is Shiny Proxy, which is Dockerized. There is no limit of sessions. However, you have one app per user. So one instance of the Docker per user. So if he will return before the Docker will kill the container, you will get the same application. And this is nice. However, you cannot warm up this application with this global data loading. So the first user will have to wait for the loading. Also, with the default config, you can visit this container if you know the port. That is quite random, I would say, but inside the range of the available port numbers that are defined in the configuration. So be careful with that. Yeah, so it's powerful, but still there are some limitations. And the last option is a little bit more advanced. So to have this app warmed up and to also have some authentication, you can use, for example, Azure Web Service with a custom Docker image. Still, you have this application containerized. However, you can enable authentication module in Azure. So you have one sign-in window for all your cloud applications, and it will be quite nicely integrated. So, for example, in case of Azure, you can integrate it with your corporate Active Directory, and you'll have to log in with the same username and password like to your PC. Still, you have to remember about those tokens to isolate your application from other users, so they will not be able to guess what is the URL or how to visit the website of the application of the other users. And you have to manage a little bit this pool of the available apps and script a little bit this process of warming them to do this global part of data loading. So to summarize, I think this is the most advanced solution, but also gives you the biggest flexibility. And Shiny Proxy, I think, should be the second choice if you are okay with this global data loading. If you are able to deal with it using, for example, lazy loading or pre-calculated data sets, that will be fine. So thank you. If you have any questions or things like that, I will be available at this YouTube channel. So do not hesitate to ask me. And I give my voice to someone else. Thank you again. See you.
Thank you very much, Jakub. That was very interesting. Our next guests are Astrid Radermacher and Matthew Dennis, and they'll be presenting supporting your community using R Shiny. The floor is yours.
Cool. I needed to unmute. Hi, everyone. Let me just slap this on presenter view. Cool. Hi, my name's Astrid Radermacher, and I'll be presenting today with my colleague, Matt Dennis. We work at Exegetic Analytics in South Africa. But this is really a little passion project that we've put together using Shiny in R, and it's about building an app for your community. So humans are inherently communal creatures. We are all getting together right now to chat about things that we enjoy. But maybe you run something like a Sunday morning bake sale and you want to record who will be selling what so that you don't have two grannies bringing the same type of cupcake. Or maybe you're running a coding challenge and want to create a quick and easy leaderboard for your community. Or maybe you want to create a space where Our Ladies community members can vote for talks or workshops that they want to attend. Basically, if you can get people to fill out a Google form, you can deploy a Shiny app that benefits your community. And why would we want to do this in R specifically? So R and Shiny are, of course, both open source. And building an app in R is very accessible to people who don't know web design. So if you know basically how to make an R Markdown document, you can probably create a Shiny app with a little bit extra effort. The caveat here is if you want your app to be cute, you need to throw in a little bit of HTML and CSS. Another benefit is that the community is super supportive. So the hashtag #RStats and #RShiny people on Twitter, shout out to y'all, very, very helpful. And if you're beginning your #RShiny journey, creating something for your community is a really great way to practice your skills. It's a very low pressure kind of way to develop your skill set. So this is kind of how the Rainbow Pages Cape Town was born. So it's an app for the LGBTQIA+ community in Cape Town. So although South Africa is one of a handful of countries where homosexuality is legal and where gay marriage and trans rights are protected, queer people here still face a high degree of discrimination and marginalization. This means that community is super important for queer people because often families withdraw financial and emotional support when a person comes out as queer or is outed. And because of the relatively small size and marginalization of our community, the internet has kind of been a place for queer people to find each other. But often this relies on your immediate social network to find friends, mentors, queer venues, queer events, and basically the support that queer people need to survive and thrive. So we wanted to streamline this kind of finding each other process by creating an app that lists LGBTQIA+ businesses, support organizations, networking events, professionals, and individual people. So something that is searchable, opt-in, and as secure as possible. Cool. So it starts with a Google form that I sent to my friends. These are some examples of the questions that are in the form. So are you answering this form on behalf of yourself or an organization or a business? And do you have their consent to do that? What are the contact details of this person or business? Please describe the activities of this person. So this is a long form question where people can put in as much detail as they would like. And then there's two checkboxes relevant to this talk anyway. So one is the suburbs in Cape Town. So where is this person or business located within Cape Town, the city? And then what sectors of the industry are this person or business or organization involved in? You know, is it activism? Is it arts? Is it science, technology? What kind of industry sector is it? And for those businesses and organizations that felt safe to do so, they could provide an address, which we've created a map with. So we excluded individuals from this because we don't want our app to be used to target people in their own homes. And sometimes, you know, people would include their address. So we wanted to account for that. So this survey goes and populates a Google Sheet. So each response to the survey becomes a row in a Google Sheet, which is then very easy to work with in R. So just another little layer of consideration here for us, like safety is really important. So even though it's, queerness is legal and there are a lot of queer people, we want to make sure that they're as safe with this list as possible because it is public. So we aren't listing raw data that we obtain from the form. We curate that data manually. So we do things like remove phone numbers and addresses of individuals if they slip through, and any other sensitive information that might leave that person vulnerable. And people can remove their listings at any time, like no questions asked. We'll just take your information down if you feel unsafe. Cool, so actually importing this Google Sheet into R, this we did with the Google Sheets 4 library, and this very simple command gs4 auth. Basically, you run this once per project, and then when you run it in RStudio, it links you to your Google Drive permissions, and you can give permissions to RStudio to access your drive and be able to import data. And then you simply use this read sheet with a link to the URL where your Google Sheet lives. So we saved this little bit of code as sheet.r, basically a .r file that we added to our git ignore. So when we're version controlling our app, this sheet is only present on my personal computer and Matt's personal computer. It's not public in the public domain. So any of these potentially harmful questions or harmful bits of information are, they're not public. So that data is not publicly accessible. Cool. And then we created another file for data manipulation and cleaning, which we did with a dplyr, magrittr, and stringer libraries. So we basically just, like I mentioned earlier, just removed any information that's not necessary or maybe is dangerous to be out in the public. And we write this data frame to a CSV file. And so this the CSV is manually curated and uploaded to GitHub. And when we deploy our Shiny app, we allow that when the Shiny app is running, it pulls from the GitHub repository. So if we update the CSV on GitHub, the Shiny app, which is deployed on shinyapps.io, is automatically curated. So is automatically updated. So only curated data is displayed in the app, and you don't have to redeploy the app every time you want to actually show the new updates in the data set, which is quite cool. Okay, so actually creating and deploying the app. So like I mentioned, we read that curated CSV from GitHub into the app.r, which we deploy locally, make sure everything looks good, and then we deploy this with shinyapps.io. So how this actually looks is we took the data and visualized it with data tables, the data tables library package, super nice. And those who have a physical location and felt safe sharing it are visualized in a leaflet map, which Matt will talk about. And we also embedded a sign-up sheet, the sign-up sheet itself, and a little suggestion box, which is also a Google form, embedded in the app as an iframe. So the entries can be added without people needing to actually leave the app and go to another website. They can just do it in the app. And then we deployed this on shinyapps.io. So shinyapps.io is a paid site, but you can host up to 5 Shiny apps for free per account. So we don't have to pay for this app, which is really nice. And this is just a little summary of the workflow that we use. So that private file, sheet.r, has the raw output from the Google form. Do any data manipulation in this datamanip.r file, which is where we curate the data. We then push that CSV to GitHub along with all of the version controlled code, the datamanip.r and the app.r files, which is actually how the app is deployed. And then we deploy that in shinyapps.io. Cool, so let's actually have a look at the app. Let me just open it here. Reload. Cool, so the app actually opens up on the repository itself. So all of the entries that we've curated are present in this little searchable table. And you can filter the table by the type, so businesses, organizations, or people. You can filter by the location, so the suburb within Cape Town, and by the activity. So for example, activism, hospitality, tourism, etc. And we've styled the app to look like the rainbow flag. So everybody is represented here. And when you filter out, for example, if you only want people, the rows don't actually, the color of the row doesn't really mean anything. It's more that when everything's together, it makes a continuous rainbow flag. Yeah, and you can search for it. For example, if you are interested in somebody maybe in the beauty industry, you can search for the beauty search key, or maybe if you're looking for a software engineer, you can type in software and 2 software engineers will come up. So as we get more users on the app, we'll have more data and it'll become a little bit more robust. But these are just the people who took a leap of faith and filled out my Google form. So Matt will discuss the app in more detail. I just wanted to show you basically how it works. So we have, again, the little activities on the left. And as you zoom into the app, you can actually look at individual premises and get information about a specific business or organization. And like I mentioned, the sign-up form is actually embedded in the app, so people can add their details here without having to leave. And a little suggestion box for complaints, critiques, compliments, suggestions, etc. So we want to engage with the community and get their feedback on the app itself. And this is just about us, like how the app is made. You can look at our repo. You can get in touch if you want to be involved. And there's also a very nice link here to the LGBTQIA+ experience in South Africa, what living as a queer person in South Africa is like. Very nice, comprehensive information pack put together. Cool, so I'm gonna hand over to Matt, who's gonna tell you about the map. Matt, are you there?
I am here.
Cool.
Hey everyone, great to be with you. For us, it's afternoon. Yeah, so I'm going to tell you a bit about how we made the map. We used the leaflet package, which makes map making super easy. And it's also really easy to integrate a leaflet map into a Shiny app. So yeah, we loved using this package. There were 3 main goals that we wanted for our map. We wanted it to have different marker icons for each business category. And when we zoomed out on the map, we wanted those markers to cluster into groups just to avoid the map from becoming too overcluttered. And then we wanted to be able to turn marker categories on and off when the users selected the checkboxes in the map panel. But before we got to before we could actually plot anything on the map, of course, we needed to geocode their addresses. We didn't ask for the precise coordinates from the users themselves, and rather from the survey respondents themselves. And it wasn't compulsory for them to submit their address. But if they did, then obviously we wanted to include them on the map. And the TMap tools package is a really easy way to do geocoding super quickly. So you can just use the geocode OSM function, plug in the address, and then you get a lovely list of the information that you need, which includes the precise coordinates of that geocoded address. Okay, so then we used custom marker icons from templatic.com, and they have about 100 or so free marker icons that we used, which was super useful. And then to make a custom marker icon, you can just use the make icon function from the leaflet package. And yeah, you can create a custom icon using a PNG file. And then to tell Leaflet to add that custom icon to the map, you just use the icon arguments in the add markers function. And it's super, super easy to create marker clusters in Leaflet. All you do is you add one line of code. It's the line that you can see there highlighted in red. And then to turn the marker layers on and off, we used the following approach. So we used, firstly, a reactive expression to filter which markers were to be added to the app, to the map. And then we used a leaflet proxy to avoid unnecessarily redrawing the static components of the map. And we just put that inside an observer. And so whenever a user selected a checkbox, that would redraw only the markers to match the selection of checkboxes that the user had used. So yeah, that's how we made the map.
Cool. Thanks so much, Matt. So I hope this inspires people to make something for their own community. I think it's, as I mentioned earlier, a really nice way to flex your Shiny muscles. So I just want to say thanks to Matt, who helped so much. And I've really loved collabing on this project with him. Thanks, Matt. And to my other colleagues at Exegetic Analytics, to the friends and queer community people in Cape Town who took the time to fill out the form. Thanks, guys. And also for consulting with me about it. To Liam Leroux for design work on the app, and thanks to the organizers today for hosting our talk. And if you want to check out our code, you can do so at the GitHub link in the slide. Thanks so much.
Sure, thank you very much. This project looks really awesome. And our next guest is Lawrence Tetzlaff, and he'll be presenting MLR3 Shiny, a graphical user interface for easy machine learning in R. The floor is yours.
Hello, great to be with you. Let me quickly share my screen. Okay. Cool, yeah. So I'm Lawrence Tetzlaff, and I'm presenting MLR3 Shiny. I'm right now trying to move this button. Anyways, in a nutshell, MLR3 Shiny is a graphical user interface for easy machine learning in R without the need of coding. And maybe before we get started, a little bit words about myself and Gero Zipanek. Gero is currently a professor at the University of Applied Sciences in Stralsund, and I'm following my master's in the Netherlands at the Geronimus Academy of Data Science. Okay, so why did we do it? First of all, as most of you know, within the recent years, in the last few years, machine learning applications have entered many industries, and open source software is readily available. For example, the powerful MLR3 framework. However, despite the easy access to those frameworks, they are quite advanced and well, highly parameterizable. So if you're a newcomer, if you're not really familiar with machine learning or with R, it can be quite overwhelming. And for this reason, we have developed MLR3 Shiny as a simple and accessible and user-friendly web application where we combine Shiny with MLR3 to provide machine learning functionalities through this graphical user interface. And this way, a user is basically able to set up quick machine learning workflows in a very fast way. And at the same time, they can familiarize with the basic steps of a machine learning process. So modern machine learning functionalities in a way can therefore be referenced and applied in an easy to use point and click fashion. And then users that are new are not overwhelmed with coding or with the machine learning theory behind it. Especially this later point makes this package quite valuable also for teaching, let's say, introductory machine learning courses and that like. And yeah, let's get right into it. So before we take a look at the application itself, I present to you the workflow. You start by importing your training data, and then you create a task. The task can be, let's say, a classification task or a regression task for supervised learning. And to solve this task, you need to select certain algorithms called learners to solve your machine learning project. These are the basics, the core building blocks, let's say, for the machine learning process. And then you have a range of selections that you can choose of, for example, the holdout split. So you use the imported training data and the learner that you selected to split the training data into a training set and test set. And you use this training set for model creation to train it and the test set that's remaining for the evaluation of this model. This is quite intuitive and it's also quite straightforward. If you want to get a little bit further, if you want to dive a little bit deeper, you can perform some resampling strategies like cross-validation or bootstrapping whatsoever. And yeah, you train the same algorithm several times, you come up with several models and aggregate the performance evaluation to hopefully have a better idea of how well this algorithm can perform on the data at hand. Finally, if you are, like, let's say, having 4 or 5 learners, 4 or 5 algorithms selected, and you would just quickly want to benchmark them to see which one of these algorithms performs best on the data, you can run a benchmark experiment and compare the models that result out of it. And finally, then you can use the best model that you identified and use all the imported data so far to train a final model, make it as robust as possible, and use this final model to predict the target variable on new imported data sets. This much to the basic workflow. So now let's go to the application itself. I prepared the iris dataset because it's quite small, so we won't spend too much time on waiting for it to train. And yeah, this is basically the welcoming page of the application. You can upload the datasets that you want, and yeah, can investigate the variables. Then you go to task. Each of these tabs up here basically is a chronologically ordered step in the machine learning workflow. And first you need to create the task, have a task ID and define a target. And all the time you have an overview of what you're currently doing so that you don't get confused. Right now, for example, we have 5 variables, one of which is the target variable, and we have a multi-class classification. We don't need to get rid of any features because, I mean, we only have 4, but if you were to have a bigger data set with features that you don't want to include, you can do that as well. Okay, next up, we have the algorithms that we want to choose of. For example, we go with the decision tree. We add a few more learners here, for example, logistic regression and some random forests. And we create them. And a useful thing here is if you want to adjust the hyperparameters, if you want to customize your learner a little bit, you can do so. For example, let's compare the same algorithm, the random forest algorithm, with different settings to see how well it performs later on. And yeah, if you have any questions during this process, click on the question mark here. There's a general description of the methodology that's applied, and then a more detailed description of the functionalities that you can use, what they are, and also what's the machine learning theory behind it. Let's start with the basic workflow, the easiest one. We have an overview. We see we didn't have any model. We don't have any model yet. We also have no training set and the test set scored. So we do a holdout split on 80% of the data. This is reproducible since we have set seeds. So in case you want to do it later on, come up with the same results, you can do that. Train the model and you predict the target variable and can investigate it. Now what we need to do, what's left, is just to score it, see how well this learner performed. You can see we have an accuracy on the test set of 85. That's okay, we didn't do any tuning yet. If right now we feel more comfortable and we want to try out resampling, we can do so. For example, we apply cross-validation with 10 iterations on the same algorithm, perform the resampling, and have an aggregated performance score that we can investigate right here. We can see, okay, this looks quite nice. In case the user is more interested, wants to get their hands on, or wants to get their hands dirty with MLR3, also with the things that they create in this application, they can easily export the data object as an RDS file and work with it. Now, finally, my application sort of got stuck. Finally, we want to go to benchmarking and compare all the 4 learners against each other. We also do cross-validation and start the benchmark experiment. We can investigate all the learners here. See, okay, this is cross-validation. We have 10 iterations, and we run the benchmark experiment. You can see here, okay, the logistic regression had some issues. We score it, and then we can see that, in fact, the random forest that we customized a little bit performs best with an accuracy of 95. Finally, we can again export this benchmark result, work with it, also use it for later steps in a different workflow, let's say. And we can again check out what is benchmarking, what are the functionalities here. So if a newcomer is confused, they can get an overview quite quick. To end this workflow, we used the learner that we identified that performs best, which was the last learner number 4, the random forest. We use all the data set or all the data of the data set that we imported, train the model on it, and we import a new data set that we want to use for prediction. So right now, give me a second. Right now we use, again, the iris dataset, of course, but this time without the species, because we want to predict them. Click on predict target and have our response. In case we want to use it later on for other workflows, we can export it as a CSV file and also as an RDS file. This is basically the concept behind it. And yeah, we can see that later on in the future, we add some pre-processing steps and, well, of course, extend the functionalities, but this is it for now. So this is it for now. And yes, so this is basically the app. A huge shout out goes to the ML3 developer team. They've been quite helpful with discussions on the design of the application and also on the layout of this application. If you want to have more information about MLR3, you can go to their website, mlr3.org. And if you feel interested in MLR3 Shiny and have remarks, thoughts, comments, ideas whatsoever, reach out on GitHub. And yeah, let's talk. Finally, if you want to use this application as a lecturer in, let's say, introductory machine learning courses, this is quite useful for getting people started, getting them interested in machine learning at hand, because it can be quite overwhelming. And there are some safeguard measures in this application itself, for example, to make sure that no false values are inserted, that like when you want to set hyperparameters, that nothing is inserted that makes no sense in a machine learning way, let's put it like that. And some default values or guidances are also given if you want to, well, have a nicely performing model directly. Yeah, so this is basically it. I'm done a little bit faster than I imagined. And yeah, in a summary, basically, this is the user-friendly web application for machine learning workflows, and also as an introduction to the MLR3 work, the MLR3 framework. Right now, I'm not accessing the YouTube channel, so I don't know if there are any questions by users. If so, I can get back to them right away, because I think we still have some time left.
Yes, thank you very much for your presentation. I believe that we have 1 more minute, although I can see that there are at least 2 questions inside the chat. So I would kindly ask you to answer them inside the chat, okay?
Okay, no problem.
Thank you very much.
Thank you.
And our next guest is Luis Martinez Uribe. and he'll present the dynamic and interactive graph visualization using netCoin. The floor is yours.
Hi, thank you very much, and hi everyone. It's a pleasure being here with you today. Let me try and share my screen very quickly. Maybe Lauren has to.
Yeah, my Zoom needs to stop. I think right now it stopped, right?
Okay, I think it's mine now. So I'll present this. Okay. So I'm Luis Martinez Uribe. I'm a PhD student at the University of Salamanca, and today we'd like to introduce an R package called netCoin that allows the creation of dynamic and interactive graphs. This is a joint project between many people. Modesto Escobar, Professor Modesto Escobar, from University of Salamanca is the leading head, but there's many other colleagues working on this project. Just as a bit of background, social network analysis can be traced back to the 1930s, and some of the first examples are Moreno's sociograms, quite well known, where he applied network graphs to understand the relationship between school pupils, and he was actually interested in learning who of those pupils wanted to sit next to each other and who wanted to actually go partying with different students to actually see the differences. We find many social network analysis packages in R. Some of them are quite well known. You've got iGraph or network D3, Viz network. Some of them have many features for you to create those graphs, and some of them are interactive. But the package that we're gonna present today, netCoin, combines the power of a very strong and solid analytical framework to study coincidence analysis with a layer of for interactivity built using JavaScript, the D3 library. So it's actually the combination of these two things that I think makes it really powerful. Just a bit of background about what is coincidence analysis. It's a set of statistical techniques that allows you to detect the events or character objects that tend to occur together in certain delimited spaces. So for instance, those spaces, we call them scenarios, and those are the unit of our analysis. And in each scenario, we can have a series of events that can occur or not. In that way, we create an incidence matrix that is a binary matrix like the one that you're seeing. With a binary matrix of that sort, where you have the scenarios in the rows and the columns are the event, you can create a coincidence matrix by multiplying the incidence matrix with this transpose matrix, and then this is the coincidence matrix is a way of projecting what we have, so that we only get the events and we see how many times they occur together, different events. And once you have this coincidence matrix, you can calculate a number of different similarity measures, matching, Rogers and Tanimoto, Jacquard, Dice, Hamann, Joule, Pearson, many of them that are possible to calculate using the netCoin package. In addition, the common relative frequencies, conditional frequencies, the Haberman or set value. Okay, if we translate this into a non-mathematical world, we can see that what we're doing is that we have bimodal networks, and those are networks that have two types of nodes, and relationships are just in between the different types of nodes. So for instance, in here, you can have users watching movies like these, or documents that contain words, authors and papers. And what we're really doing is projecting those networks from mode 2 to a mode 1. You can see it here. Like if we have a mode 2 network with users and items, this can be projected into a user projection or an items projection. And this is really what we're doing with the coincidence analysis framework. And really the power of it is that these relationships and their strength is calculated using a variety of measures. So the other great thing about netCoin is that you only need a few lines of code to create interactive graphs. So for instance, if you just install it and load the library, you can load one of the data sets that come with the package, which is the dice data set, where you roll the dice several times, 6 times, and you get different results. So you get like the incidence matrix that I was presenting you before. And just with a couple more commands, you can plot a very simple and nice interactive network where you can play with the nodes and change the size of the nodes, of the links, the colors, etc., etc. And I'll be showing you more examples of how it works. And then netCoin, it provides many other useful integrations and features. Among them, there's several functions, like from iGraph and to iGraph, that produces networks from iGraph objects. So it's a nice connection with iGraph. Or you can also use, you can save the network object that you've created with netCoin into Pajek, which is another network software that is widely used. Or you can include those networks that you produce into Shiny to include it in your dashboards. And then there's a wide range of functions that allow you to create regression graphs, network correlations, useful for structural equation models or for survey data, coincidences in time, or coincidences in bar graphs. And I'll be showing you examples of all these. I've got 4 examples here on applications of netCoin. This is using a wide variety of areas. I'm gonna try and show you these 4. So for instance, if we look at for the use of netCoin in social surveys, this is from the European Social Survey, and you can see this is how it looks when you create a network with netCoin. It's all interactive, and you can play around with different controls for distance, repulsion, or the zoom. You can convert this into a heat map or a triangle for seeing the correlation in between these things. But really, what we've seen here is political participation in Europe, and how these forms of political participation people tend to use these forms together. It's clear, I think, if I show this other graph where we have different types of variables plot together with the relationships, but I can maybe look at the participation and age and filter the graph by these. And it's obvious here how participation in the form of petitions or online or demonstrations are kind of, the younger use them more, and the older tend to do that political participation through associations, groups, or politics, get involved into politics. So this is one way in which netCoin can be used for social services. It can also use for social media, and this example is a dynamic network in Twitter. So it's actually, we can play it a little bit, but this is a net of retweets of a particular hashtag. In Spanish is Cuéntalo, which in English is Me Too, and it's for sexual harassment. And you can see how people are retweeting themselves and retweeting other people, and how this network grows. And this can be played, and it's all dynamic, and those are the retweets every hour. So you can create networks that actually change in time and visualize that change in time. There's 2 more uses that I want to show you. There's one in digital humanities, and this is showing the most popular operas from some of the best composers. And the data is gathered from this site, operaareas.com. And something interesting here is that you can use images for the notes. And not only that, but those notes are linked to their Wikipedia pages. So you can turn these graphs into a useful way to teach students or present information related to humanities. The last example that I want to show you today is this on content analysis. This is a project from a colleague at the University of Salamanca, and what she did is she performed a content analysis on women's blog, and she was actually adding different tags to the different posts in the blogs, many tags for each of the posts, and through this bar graph you can actually see the coincidences of the different terms. So for instance, if we choose one term like feminism, you can see how these are the coincidence with violence, and the lighter blue shows like the time violence appears, and how it coincides with feminism. Okay, so this is yet another use that can be applied to netCoin. Okay, and just to finish, I include the email addresses of all the colleagues involved, and I include the article that it was published some weeks ago in the Journal of Statistical Software that goes into more depth into all the elements of the package, of the netCoin package. So please feel free to read it, and that's it. Thank you very much.
Yes, thank you very much. That was really great. We still have 2 minutes. I don't see any questions at the moment inside our chat.
I'll be following the chat in YouTube, in your channel. So if something comes along, I'll be happy to answer the questions.
Okay, great. However, I can see that our very last guest did not arrive yet. So maybe is there something that you would like to show additionally that connects to the presentation?
I can see one question coming.
Okay.
Is asking whether these visualizations are Shiny apps built around netCoin, or they are integral part of netCoin. They are not Shiny apps. When we started developing netCoin, we started plotting the information using Shiny, but then we discovered the D3, the library in JavaScript that allows the creation of these very, very nice interactive network graphs. And so we stopped using Shiny, but there's a way in which you can actually include these visualizations into a Shiny app.
Okay, great. Thank you for the answer. We can wait for more questions. Okay. Oh, I can see another question. Oh, but I guess it's about MLR3. Okay.
Okay.
But okay, there is a next question about network coincidence from Colin. So could you please address?
Yeah, the other question is, can the network coincidence analysis be used in a business environment? For instance, e-commerce, interaction between shopping events? Yeah, why not? I think the strength of netCoin is actually that you can apply that coincidence analysis framework to pretty much anything you want. So if you want to check, if you want to see, for instance, the type of users that tend to buy similar things and plot it and see the relationships, the relationship between the items they buy or the relationships between the users, this could prove to be very useful to you. So I do please investigate it and use it. And if you have any problems, do get back to us and ask us any questions. We'll be happy to help.
Okay, thank you very much, Luis, for your presentation and for the answers. And our next guest is Stefano Guidi, and the topic is Adapt Data Viz Tool, a Shiny app to explore ATM network optimization models. The floor is yours. Hello, Stefano. You're muted.
Hi, can you hear me?
Yes, now we can hear you.
Okay, thank you very much. Hi, Christoph, and hi, everybody. I am trying to share my screen or the presentation that I prepared. Haven't used Zoom in a while, so sorry, just a sec. So just share Microsoft PowerPoint. I think it's this one. All right. Okay, share. It's asking me some, right. Okay. Is it showing? No. Do you see my screen? Okay, this is it. This it?
Oh, okay, something changed. Yes, we can totally see your screen now.
Okay, thanks. Good. Finally, so let me start the presentation. Okay, so this is this topic. This is my talk is about this tool that we've built with my colleagues in Deep Blue within the context of a EU-funded project. The project was called Adapt, and it was about optimizing the air traffic network to improve performance and minimize the impact on the capacity of the aerospace sectors. So I will first give you a brief outline of the problem and some information about the ADAPT project. And I will present this tool that we've built as part of this project to show these results of these models that try to optimize the airspace configurations and define routes of airplanes or flights, and starting departure and arrival times in order to minimize the impact on the network of air traffic network. So the current planning of the ATM system, it's based. There is a high level of planning flexibility. So usually flight plans for a day are submitted for a flight are submitted only a few hours before the operation. So before the flight is actually supposed to depart. This is called the tactical phase in the context of air traffic control. and usually the airspace sectors in which the airspace of above countries or above Europe is divided, which are three-dimensional volumes of space with horizontal lateral boundaries and vertical flight level boundaries, are established quite in advance, in strategic phase, so about a year in advance, and are often, oops, what happened? Sorry, and are updated generally only a few days before the operation of the flight. And for each air traffic sectors, you allot some staff, some air traffic controller, which are in charge, when on duty, they coordinate with other sectors the arrival, the entry of flights, of planes within their sectors, in order to maintain separation, vertical or lateral separation between flights to keep the flight safe. So to avoid possible accidents and collisions between airplanes, or when they're flying, or when they are entering and approaching an airport, and so to land, and when they're also departing, so to make sure that the use of the routes on the runways and the traffic on the ground is safe and distanced. So usually the fact that the capacity provision is planned much in advance sometimes causes system delay, because something happens and you have an air controller that is in charge of a sector for a given time is usually able to control, to be in charge of a limited number of planes, and this is called the capacity. But sometimes for some problems that might be on the route, because the flight starts late, or because it finds along this route finds some bad weather, so it needs to take be rerouted in other ways. It arrives in the sector late, and this can cause problems with the capacity. So there might be not enough capacity in the sectors. And so to avoid these, there are further delays in the flights that have to be rerouted and kept flying, with cost and pollution and a lot of side effects. So, and of course, when the traffic is, when a sector is operating in a high capacity, there can be problems with safety. So the DAT projects wanted to try to use a set of tools and methods to create some models to enable strategic planning and of the sector. So we use the models that were developed by the engineers in the University of Trieste and of Palermo, try to increase the predictability of flights, which means the time at which each flights are supposed to enter in a given sector, while preserving a certain amount of flexibility in order to accommodate possible problems that might happen in tactical phase and once the flight has departed. So it's quite a complex background. So flexibility is in this project is defined in terms of time window. So time intervals that are associated for each flight segment, because the flight route is divided in a set of segments, and starting from departure to arrival, and with some points that marks the entry in given sectors. So this time windows is a measure of flexibility that is in this project is assigned to each flight, or to each segment of the flight. And it's characterized by the position, the opening time, and the duration. So the higher is the duration, the higher is the flexibility of the flight to enter given sectors. and it can be forward from the time it starts, can extend even backward before the supposed departure time or entry time in the sectors, and symmetrically or asymmetrically with respect to the position, the opening time. And which is the time period in which the action, so the entry to the departure, the entry to in a sector, is supposed to be executed to minimize the cost. And so the greater is the time window, the higher is the flexibility granted to the flights. And these models basically try to use all the flights from a given day in that was, I think, September 1st, 2017, to compute the best routes for the flights, and to compute some metrics for each flights in terms of how they can, how flexible there can be their entry in given times during the day in the various sectors in which the airspace is divided. So they try to respect they assign the trajectory to each scheduled flight, to respect the capacity of the network, guarantee there is predictability and flexibility, and minimize the flight's operational cost. So it's highly technical. I'm not an engineer, so I wasn't involved in this part of creating this optimization model, which were run on a separate, were not run with my computers, but only with the servers in the University of Trieste. And what I tried to do is to try to build a tool to visualize this information, the results of this computational model that accept several parameters in terms of optimization, for optimizing the trajectory and the departure times of all the flights, and to visualize them in a way that could be useful for operators of different actors of different kinds that works in the ATM sector. So network managers, air traffic controllers, airlines, airports, in order to enable collaborate decision making that involves all the actors in a strategic phase. So this is I built this Shiny app that features both interactive and static maps and interactive plots of the results and of the metrics of the impact of the flights and of the load of how each flight can be impacted by the number of flights that can be constrained to pass through at a given hours. And it was built using Shiny Dashboard Plus to have a lot of flexibility in where to put the type of controls that to use, and with SF and leaflet package and Plotly. Let me show you just the interface, screenshot of the interface to explain you where the main parts of the interface. So we have a toolbar with some two drop-down menus that allows to set, first of all, the model parameters, and secondly, the settings of the view, because you have to understand that, like, during the day, for the way sectors are configured, is that they have a certain shape, a 3D shape, and that varies during the day. So there are certain times when maybe you merge two blocks of two sectors to make a bigger one, because you know that there's going to be less traffic. So maybe just a single controller is sufficient to handle the traffic that is supposed to enter in that time. So the airspace configuration varies through the day, and also the shape of the sectors, and also they have flight boundaries, upper and lower boundaries. So that means that you cannot show on a flat surface the real structure of the sectors. So you have to somehow flatten it and take a horizontal slice of the airspace sectors in order to show this result. currently. I want to briefly try to exit this presentation to show you the, let me see, I'll stop the sharing and try to show you the tool live. So that, all right, okay, this one. Can you see it?
Yes, we can see adapted data visualization tool.
So this is live. This is on the website, on the server that we put. So you see that we have the parameters of the models that you set, the duration, the minimum duration of the time windows, some criteria to optimize the as I was talking before, these time windows can be asymmetric around the time of entry, or can be only forward, or can be symmetric. So from here, you can change the settings to show the impact on the network. And also from this other menu, you can set the flight level, the slide where you slice the airspace volumes, and the time of the day in which you show the results. And change different kind of metrics that you use to for the correlate maps of the sectors. So now I'm showing the use capacity, but you can display the colored sectors based on the spare capacity. So how much left planes could be handled in that given hour by a controller, and so forth. And whenever you click on a sector, it shows you further information, and basically it shows the flights that pass through that the constraint that in that hour are associated with that sector. And on the sidebar, you can see some metrics about the criticality index, so how much it's highly technical, but it's a metric of the impact of the flights of the flights that you have in that sector. You can zoom in on each sector. You can display, clicking on each flight, further information about that flight, so the origin, the destination, the type of plane that it's flying, and some measure about the flexibility of the flight. And you have also a table. Probably I need to update the CSS because now it shows with different colors, but that was built about a year ago. And you can see all the constrained flights from that sector, which are the flights that don't have much flexibility for that sector. And you can show them a map and highlight for each sector and display different information.
Okay,
excuse
me, Stefano, but unfortunately we are out of time. We have to start another session. Thank you very much for participating. Thank all of you, both lecturers and people on chat, and have a nice day and enjoy the rest of the sessions.
Thank you.
Bye.
Bye-bye.